Hey guys, welcome back. So we're going to an AC call. The customer has a downstairs unit and an upstairs unit. The customer said that one of the units is not working. I believe it's the upstairs, but we're gonna go ahead. We're gonna go over there. We're gonna figure out the situation, and we're gonna get the customer back up and cool it. So you guys stay with me, and let's get to it. All right, you guys. So it's the upstairs unit that's not working. So we're gonna go to the back. Close that gate. All right, and then it's gonna be this unit on the left right here. So let's get it started, start diagnosing the issue, and then we'll be able to figure out what's going on. All right, let's go ahead and start here. Thank you very much. Thank you. Oh, drop the screw. Alright, so first let's take off this panel. So the main issue at first was when the AC was turned on, the fan motor was not spinning, but the compressor was running. So what we're gonna do, this looks like the original capacitor right here from this unit, and this unit is definitely about over 20 years old for sure. So let's go ahead and check this capacitor real quick. Go ahead and check this guy out. I'm pretty sure it is the capacitor because it's the original one, and this is a 40 capacitor. Okay, no problem. So let's go ahead and get this Herm side off real quick. Discharge it. Alright, let's turn on our meter. Let's test for MFD. So this is our common side right here. We're going to test on leads, common to Herm. This is a 40 cap, and on the compressor side, it's reading 38. So the compressor side is still good. Let's check the fan side, which the fan was failing. So let's check fan to common. If I can do this, hold on 1 second. Fan to common, we are getting 3. So seems like, because this is a 40 plus 3, as you can see right there. So the fan motor might be failing. So what I'm gonna do is test it out real quick. Let's hook this capacitor back up. It's the fan side. Herm side. Got back in here real quick. So let me check. What I'm going to do first, just want to make sure this fan motor is designed for 3 microfarads. Sorry, I could not find it. Okay. So we have a bad fan motor here, so the capacitor inside the unit is still good. As I try to spin this fan blade, as you can see, it's not rotating really much at all. It has no free spin to it at all. And this one is completely rusted out, seizing up, not spinning. It has the 3 MFD that's been designed for the system since the installation of it. This is a 3 MFD fan motor, so yeah, it is bad. It is getting the voltage. Customer wants me to check this system, their other system out really quickly, just to make sure, you know, capacitor and everything's still good. So we'll go ahead and get started doing on that, and then we'll go ahead and go get that fan motor if so that way we could get them repaired. Okay, so I checked the other system right here. So this capacitor is still reading good on the capacitor side for the Herm and the fan motor side. But what I'm thinking about doing is adding a hard start kit to this unit, just so it helps it in the future, because this is the original capacitor, and you know, we don't want to have any issues with the system later on. So I'm probably going to offer a hard start kit for this one, but we need to change the fan motor out for the other unit with the capacitor for this unit right here. We need to change out the fan motor, add a new capacitor, possibly a hard start kit, you know, just for how old the units are. Maybe give it a little wash down on the coil, because the coil is getting a little dirty. But I will update you guys once we get that fan motor. The customer wants to go ahead and repair the unit, so I'm gonna go down here to the local parts shop. We're gonna grab this fan motor, a capacitor, and then we're gonna go ahead and go repair it. So I'll get back to you guys as soon as we get it. Got the fan motor, so we're gonna be replacing this fan motor right here. And then we got 2 hard start kits. We have the SPP5. This is going to be for the 3.5 ton unit. And then we have the SPP6. This is going to be for the 4 ton / 5 ton unit. So we have to put a bigger one on a 4 or 5 ton unit, and then when it's about a 1 to 3.5 ton, we put the smaller ones on there. Then we have a 40 plus 7.5. 7.5 is the MFD for this motor, and 40 is the designed MFD for that unit. So we're going to be replacing this capacitor as well. So let's go ahead, let's get started. Let's go get this done. Get this open. Alright, so let's get started. Power's off, disconnect, pulled. So let's go ahead and start taking these screws out. So what I'm doing, I'm taking off the top case. This is to hold the where the fan motor spins. We have to remove this top plate in order to get the fan motor out. I usually like to store my screws up on top of the disconnect, just so we don't end up losing them. So I put them up here on the disconnect right here. And let's go ahead and take off this side panel. Rest of the screws there. Alright, I'm going to disconnect this fan. Oh, we're going to take all these wires out, but let's go ahead and disconnect this. Okay, so this is one of those old type units, so all we need to do is just disconnect this fan motor right here. We don't even really need to do anything with this, but the old fan motor was attached to this module right here, which connects to here, and that sends the power, you know, going to red, brown, and then black. So let's go ahead, put my screw up here. Oops. So got the fan motor there, and then we don't need to worry about this right now. Let's get this fan motor taken off. I like to use some of my wrenches. Just take my bag over here. And get my pad. Just so we don't hurt our knees. You know, it's always good to keep your knees nice and comfy, because after a while your knees are gonna start hurting for sure. Go ahead, loosen this bolt. So this bolt ends up holding the fan motor in place. Just gotta loosen it. It is pretty old, so sometimes you need to give it a little budge. There we go. Alright, let's see if this fan motor is going to give me any play. I'll try to spin the shaft from underneath, because there's no extra shaft here. Usually I'll grab it up top and I'll just try to spin it, but it's not much I can work with. I might just try to pull this guy off, honestly, because there's not much I could do. Alright, after tackling that fan blade, finally got it off. But let's go ahead and get this other attachment for the fan blade off. I usually suggest using this type of bit. It's a universal bit. Easy to get these little caps off. Come off right away. Alright, so that fan motor's off. Let's go ahead and get the new one right on. Gotta take off this insulation. This is to insulate the wires, so that way they don't get caught up in the blade. So that's trash. Alright, let's get the new one. Damn, so alright. Oh, that would have been bad. You know, playing around, they were trying to end my day. Sniper trying to end my day. It was telling me, nope. Alright. Condenser fan motor, as you guys can see, 1.5, 1075 RPM. That's what the old motor had, and it uses a 7.5 on that 1.5. Alright, and so these two brown wires, will attach to a new capacitor, but you could actually cut the brown / white wire and put a wire nut on it, and then you could use this main brown wire right here to just be on a dual capacitor. That's what I'm gonna do. And then the black and the yellow, these are gonna be our line voltage. So we're gonna go ahead, we're gonna get this motor attached real quick, and then we'll get this unit up and running. So we got the fan motor replaced. It is cooling. It's spinning. Alright, we placed a hard start kit in here with the new capacitor. I'm gonna clean up these wires, but we have the hard start kit, new capacitor, same contactor. Contactor's still good, so we'll keep that same contactor in here. But the unit is cooling. Let's go ahead and check the pressures real quick. Well, actually, let's do an amp draw. So let's do an amp draw on the fan motor. So we're getting 1.25 off the fan motor, and yeah, I'll put a temperature. I'm gonna put a temperature thing on there. Okay, give me 1 second. The amps. I'm gonna read on this motor really quickly. The amps for this motor is 2.8. So we're in a good range right here. And then let's check the compressor amps. Well, let's check the main voltage for the compressor, which is gonna be this black cord right here. So we're getting about 16 amps. And then the design amps on here. Okay, RLA is 17.1. So I mean, it's under, but it is pretty close. I'm gonna test it one more time. Alright. So I mean, it's kind of borderline, but it's still under. That's the good thing. It's still under. So let's check the charge inside the system really quickly. Grab my suction line. This on the liquid line. Alright. Go ahead and check this real quick. So for R22, I mean, this pressure looks pretty good. Just testing it. I'm gonna go inside, test temperatures really quickly to see what the temperature is coming out on the supply side, and I'll get right back to you guys. Alright, so we got about 65 degrees in the upstairs. So this is the unit that we repaired. We got about 65 degrees right now coming out of the supply. It is about 84 in the house, so 84 minus 65 with about a 19 degree split. That's good. It's not bad, but it's good. But I'm gonna go downstairs really quickly. They want me to check the charge on the downstairs unit because it was not I would say cooling very efficiently. So I'm gonna check the refrigerant level on that really quickly just to make sure everything's working right. But right now we're getting about 64.9 degrees coming out of this register's upstairs, and it's still dropping. So I'm sure it'll get colder. We'll just keep an eye on it. All right, so for this unit right here, this is for the downstairs. It looks like this unit's really low in refrigerant. It only has 25 psi. It definitely needs to be around like 60 or 70 psi. So I'm going to talk to the customer about doing a recharge. But you know, if not, then yeah, this unit's probably, it definitely has a leak. So I'm gonna discuss this with the customer, and we'll see where this goes. All right, so they agreed to pump in some R22. So we're gonna go ahead and get this R22 pumped in, and we'll get this unit up and cooling. All right, once we get it up and once we get the pressures right, we'll go inside, we'll test temperatures for the downstairs, and then we'll make sure everything's working, and then the customers will be satisfied. Okay, so we recharged the system for the downstairs. Right now we're at 75 psi, looking good. Most pressures. Oh yeah, you can already feel the difference down here.
You can already feel the difference.
Yeah. Let me go ahead and just test the air. Let's go ahead and turn this guy on. I'm gonna go grab that step stool really quickly. Yeah.
Checking that bonus room that's in the corner.
Yeah, the one that.
The big room over here.
Okay. Yeah. Let me go ahead and check it right now. Bonus room right here in the corner. Boom, 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 boom. Grab my step ladder real quick. There is a register right above me. So I'm just gonna check this real quick. So the way that these supply register devices work, as you can see, you can put it up there at the register and you'll get a live reading right here on your phone. So right now we're just kind of testing for the upstairs. We're looking at this top number right here on the supply side, just to make sure it's still cooling. Yeah, it's still dropping down. What is that, about 65? 64.8? Okay, still dropping. Go ahead and attach this back there. So you guys can see it's still dropping, so 63. Alright. Let's go test it. Let's go test it downstairs now. Okay, you're at about 63, but it was still dropping in that room.
Perfect. Okay. Sounds great.
And we'll go ahead and test this one. I like this little device. See what readings we get for this one. So even for downstairs, right now we're at 61, it's dropping 60. Yeah, we're gonna get to probably like 52 at the rate it's dropping.
I can already feel it.
Oh yeah,
Coming out of those things.
it's coming out good.
Well, hopefully it holds in that line, right? There's no.
Hopefully, yeah.
That leak. Yeah.
Exactly.
Okay.
Just make sure. Yeah, so we're definitely cooling at the downstairs as well. All right, you guys, so we went ahead, got this unit up and cooling, and we also got the unit behind me up and cooling. This one I pumped in R22 with some leak seal. Hopefully that gets, hopefully that seals up that leak. I offered, leak check and everything for the customer, but they'd rather just pump in the refrigerant and, hope that this unit will stay up and going for the next year so they can prepare to replace it. And then I don't know why I did that, but all right. But yeah, we're gonna go ahead, tidy up everything, and I'll see you guys in a minute. All right, mission accomplished. So it started out as the upstairs unit wasn't working, but we got that one repaired, and then the downstairs, they realized that wasn't really cooling very efficiently, but we got that repaired and they are all set. So customer's happy. We checked temperatures, they're both blowing out under 60 degrees, so we're all good. It's 100 degrees outside. Have both about a 20-21 degree split, so the customers are very satisfied. But I appreciate you guys. Hit me with a follow, subscribe. Catch you guys later.